Okay, so we are going to do the last set of notes over trajectory, and then we're going to practice it. So remember, if you get lost today, this is probably this is the hardest part of ballistics for sure, because the other parts really are not hard. It's just some basic stuff. But this part, actually calculating the trajectory, the angle the bullet came in, more complicated. Still not that hard, but if you need help with it, there are like examples in the assignment today that are fully worked out for you, so you can kind of see step by step. But if that is not enough, then join the Google Meet, and I'll walk you through problems. Okay. So trajectory is the path of the propelled bullet. Ballistic evidence can help experts determine trajectory and therefore figure out where a shooter was located during a crime. So trying to figure out where they were at, checking the cameras, somebody how you can get like how tall they were, and things like that. 2 reference points are needed to calculate trajectory. So a reference point can be the bullet hole, the gunshot residue, an empty cartridge, entry and exit points of the victim. Pythagorean theorem can be used for triangulation as long as you have 2 reference points. So basically, trying to figure out here, path of the bullet is C, how tall we think they were, how far apart we think they were. So a building is 60 feet away along the horizon line. The bullet hole is 4 feet above the ground. So we were saying, if I look in here, so it's 60 feet away, 4 feet off the ground is where the bullet hole is at. Where is the shooter located? B right here, is where the shooter is located. Find the length of B to C. The ABC triangle has the same proportions as the ABC triangle. So basically, you just do the formula. Okay, so using use Pythagorean's theorem has the steps right here. So AB squared equals AC squared plus BC squared. And it sounds complicated, but I mean, you really do just kind of like plug numbers in and then you know what to do. Okay. So AB is over A over C, AB is over AC. So keep in mind that a bullet's path may be slightly curved due to gravity pulling downward on the bullet as it propels forward, especially when shot from long distances. So the further away the shooter is, the more gravity is going to impact it. So then you might be a little off. So when I say that you can get the height of a shooter, you can, but the further away they were when they shot the bullet or when they shot the gun, it's going to like mess it up a little bit of their height. So like you'd like, okay, they're like ish high, not like this is definitely exactly where it came from, because gravity is going to affect the outcome. Wind, speed, and direction may also affect trajectory. Okay. We can't change the laws of science, but by placing a sight on the top of a rifle, we compensate for the differences between straight line optics and curved trajectory by combining the two. This angle, exaggerated in the illustration, is what accounts for the idea of a rising bullet. Although the bullet does pass through the line of sight from below, it never rises above the line of departure. So the bullet's never going to be higher than the laser. We just know. And this is where they were aiming, but gravity could pull it down, is what that's saying. Okay, that's really the end of the notes. So what I'm really going to do is I know that didn't make a lot of sense because mostly what my plan in class was just to walk you through the problem. So that's what I feel like I should do in these notes. It's really just walk you through an example problem. Okay. So when you open up your assignment for today, it looks like this. Copy of calculating trajectory, external ballistics, digital tutorial. So all those words, we're calculating the trajectory. So you have external ballistics here. Okay. So there's going to be a type 1 problem where you know from where the shot came and the distance the bullet traveled. Example, if you know that someone was shot from a particular building, but you want to figure out if they were on the roof or shooting from the window. So basically you're looking for height. Type 2 is the angle that the bullet struck. This is more likely what you would encounter in the field. So a lot of, there's more examples of type 2 because it's just more common. So here we go, type 1. Like I said, the first one is always going to walk you through it and is going to ask you to repeat the steps. So to do this next set of problems, we need to review some calculator functions. You can use a scientific or graphing calculator, your phone or online calculator such as Desmos. So locate the X2 button. Okay, so that little button there that has the little X2. So that's your exponent button on the calculator. This button is used for finding what happens when you square a number. So we're going to need to square a number to be able to do this. Let's pretend we need to find 5 squared. Okay, so I put in 5 squared, and that should equal 25, because 5 times 5 is 25. Locate the button, this little square root button. Okay, so we're going to find the square root button. So on my scientific calculators, for the ones we have here in class, I'm going to have to hit the second and then that same button that I was using already, and now it has the square function. So I had it second and then that to make it pull up. So you figure out how to get your square button to work. And it says, let's pretend we need to find the square root of 25. So put 25 in there, and it should equal 5 back. Okay, so those are kind of the 2 functions we're going to need to be able to use. Here's your practice problem, known flight path. So case A, in 2005, Johnny W. was sitting in the front seat of his truck outside of his office about to enjoy his lunch. He had just purchased from Good Burger. Just as he is about to take a bite, he is hit in the arm with a bullet. He survives. Police begin to investigate and are able to determine several things in the course of their investigation. They suspect the shooter was somewhere in the office building when they fired the fatal shot, okay, even though he really survived. Johnny was parked 32 feet away, so he's sitting in his car, right? He's 32 feet away from the building. They think the shooter came from somewhere in the building. The bullet traveled 52 feet. The bullet struck Johnny approximately 6 feet off the ground. So he's 6 feet up, okay? You need to figure out what floor the shooter was fired from. So basically, the importance of his height here is when you figure out how high the shooter was, you're going to have to subtract off that 6 feet because he's technically 6 feet off the ground. Okay, so now to solve it. So we have our little triangle here. Take a look at the shape you made with the flight of the bullet and the distance of the building, these triangle shapes. Time to dust off your math skills. Pythagorean theorem is a squared plus b squared equals c squared. And this is a, is the height. Long part is c. Distance away from the building is b. Okay, in this case, we know the b and c part. So we have the answer to b and we have the answer to c. We're trying to find a, trying to find the height up, how high, what floor was the shooter at. So basically, how do I get this by itself? Remember, to get it by itself, I do the opposite of what's happening to it. So it's being added, so I'm going to subtract it over. So it's going to be c squared minus b squared equals a squared. Okay, so all we really put in the calculator, I'll show you the next one, is, so the c was 52, so it's 52 squared, minus b, which is 32 squared. So you get the answers of them squared, you subtract them, you get this, and that's a squared. So a by itself though, okay, so I want to know just a, remember, because that was not a squared, I want to know just a is the height. So to get it unsquared, I go second, X squared button, and it makes that square root. So I'm going to do the square root of it. They kind of left that out. So you do the square root of 1,680, and you get 40.99. So they're 40.99 up. Remember, the bullet struck 6 feet off the ground, so you would need to add that to the height you just calculated to get the height of the shot field. Oh, you add it. Okay, so he's 6 feet up already. We're saying another 41 feet up. So really, he's even higher. Okay, so you add it. So 41 plus 6 is 47, and that's how high up. So then you just figure out, well, how many, like, what is the height of each floor? So here you'd look, okay, first floor, 10 feet, second floor to 20 feet, third floor goes to 30 feet, fourth floor goes to 40 feet, the fifth floor goes to 50 feet, and we just stated that we're at 47, so that's the floor we're on. He's on the 5th floor. So someone shot Johnny from the 5th floor of his building. This just happens to be where his former business partner's office is. He was arrested and charged with attempted murder after security footage showed he was in his office at the time of the shooting. And there you go. Okay, now you're gonna do the same thing. So do the exact same math problems. You can go back and look at it for those two problems. Now type 2, you have different calculator review, so different buttons. Remember, this is not when I don't know height. The second type of problem is when I know the angle. So I know the angle the bullet hit. Okay, so what I need to know now is, depending on the calculator, you might need the angle in before, or after pushing the tan button, you might have to play with it. So let's pretend the angle we'll be working with is 45 degrees. So type tan. So you're going to find the tan button. Mine just says tan, T-E-A-N, and put 45. You should get the answer 1. I did. Okay, so my calculator is functioning properly. That's the point of this, is to make sure that you're getting the right answers. If you get the answer 1.6, you need to fix the setup on your calculator. Make sure that your calculator is set up to work in degrees. So if you get 1.6, it's because it's not in degrees and you need to change it. You'd go to second science function and change it to degrees. If you get an error, try typing the 45 before you hit tan. So there's just some calculators that you have to hit the angled number in before you hit tan. So if it says error, that could be why. All right, so vocabulary review, adjacent means next to. This flamingo is adjacent to flamingo B. So if they say that in a problem, like this was adjacent to this, and it's the two sides that are closest to each other, all right? All right, so here's case B. In 2020, Sally M was sitting in the front seat of her truck outside of her office about to enjoy ice cream she had just purchased from Dairy Queen. Just as she is about to take a bite, she gets hit in the arm with a bullet and she survives. The police begin to investigate and determine several things. The suspect, that the shooter, was somewhere in the office building when they fired the fatal shot. Sally was parked 30 feet from the building. The angle the bullet hit was 53 degrees. So they know the angle based on the shape of the wound, or the shape that it made in the wall impression. So that's how they're figuring out the angle, is they're having to calculate it from the bullet shape itself, the bullet entryway. It's kind of like the shape of when we did blood drops, like perfectly round means it hits 90 degrees. Same concept. So if it's a perfectly round circle, they were 90 degrees of them, shot them. If it's any bit angled, then they were higher or lower, and you have to figure out exactly that angle. So in this case, it's 53 degrees. The bullet struck Sally approximately 6 feet off the ground. You need to figure out what floor the shooter was on when they fired the gun. So all we do, same kind of thing, we have a different calculation. So once again, we are dealing with a triangle. So we can use the math to help solve the problem where a shooter was. In this scenario, we know what the angle the bullet hit, and we know how far away from the building. We will label the legs of our triangle in relation to the angle that we know. Okay, so when you know the angle here, the one that it is touching is called the hypotenuse. The angle that it is, or the side that is not touching the angle that you know, is called the opposite. Okay, so opposite is the leg which is directly across from the angle you know. Adjacent is the leg which is next to the known angle. The hypotenuse is the longest leg. So this is adjacent. This is the one opposite of it, and this is hypotenuse, which is the longest angle from it. Okay. So a little math review, we need to use some functions of our calculator that you may not be used to using. We are now going to use the tan button, which stands for tangent, and it is a magical little button. Trigonometry is just a study of triangles, the study of their angles, and the study of the length of their sides. For ballistics problems, we will use the study of scenario B. We'll be looking at one particular function in the trigonometry, tangent or tan. So tangent is the ratio of the length of the opposite side to that of the adjacent side. So we're looking at these two. So basically you have tan equals opposite over adjacent. So opposite divided by adjacent. Back to the case. So to get we know the angle, right? We know the angle is 53 degrees, and we're trying to figure out what opposite is. I know adjacent. So that's what, when I'm filling this in, I know the angle, it's 53 degrees. I know adjacent is 30 feet from the building. I don't know how tall or what floor the shooter was on. I don't know opposite. That's what I'm looking for. So tan of the angle, so basically I want to get opposite by itself. How did I do that? Well, if it's being divided right now, I multiply it over. So now tan of angle, which is the angle, times adjacent is equal to opposite, which is what I want. So I just had to move the formula around. So opposite equals tan 53, because that's the angle. Tan of the angle is tan of 53 degrees, times the adjacent, which is 30 feet. That equals 1.33 times 30. So I can put that in to make sure. So I go tan 53 I also got 1.33. And then I multiplied that by 30 because that's the adjacent. And I got 39.8. Mine was rounded a little higher. So rounding up, rounds up to a 40. So we're dealing with the opposite is 40. But remember, they were hit 6 feet off the ground in their truck. So really 6 feet up, then plus the 40. So 46 feet off the ground. So when I'm looking at what floor they're on, 40 to 50 is, our answer is 46. So 40 to 50 is in between that. So they were on the 5th floor again. Okay. So Sally was shot from the 5th floor of the building. This so happens to be where the headquarters of the rival company is. The CEO was found and arrested after the gun was found in his possession. So it just showed you 2 ways to get height, 2 different formulas. So I could either have the measurements here and here and do the first formula, or I can have the angle that I know the bullet came in at and just the distance away, which that's usually what you have. You don't usually know exactly how far the bullet came from. It's usually an issue to know that. So usually you're going to have the angle because of the shape of the bullet hole. And then you're going to know how far they were away because you have your victim laying there. So you know how far away they were from where you think the possible shooter came from a car, from a building, from a house, something like that. And now you just do the same kind of problem. So again, if you're still struggling, go back up, literally follow the steps, step by step. You only have, I think, 2 problems in each one. So it's not that much, but if you struggle, get on the Google Meet. All right.